Hey y'all, thank you so much for coming by. If you are not Dr. John, I highly recommend that you skip over this excruciatingly boring video and take my recommendation and we'll go watch Dr. Leopoldo Armesto's videos regarding the CoppeliaSim tutorial. They're very concise and very well spoken, and he is the king. So this is just my brief introductory overview of goofing around with the software and trying to learn it. So without further ado, thank you, Dr. Jung, for coming by, and let's get started. So I'm here to give you a brief introduction to CoppeliaSim Player. It's a software that was formerly known as VREP to control and simulate your robotics. So without further ado, I'm going to show you how, given whatever browser you use, just type in CoppeliaRobotics.com with 2 P's, click on this download button in the upper right hand corner, and then I clicked on the player version, that is like the introductory trial version. And then when you click the download button, you get some options. I clicked on the installer package because it's my personal computer, and then it'll go ahead and download everything into your downloads folder. And then once you have that, you unpack it, it'll install everything into basically your C drive, and then your program files, your Coppelia Robotics is going to be your main folder for this. And this is going to be your opening home screen. You're just going to have a floor and like no walls. So you see on the left side it says model browser. This is going to list out all the different kinds of models that you have either preloaded or that you can load, and right next to it you'll have your scene hierarchies. You can like stack scenes and stuff. These 2 pluses on the left side are to control your floor. And this controls like your basic camera pan, and then this rotating guy is like your angle, basically. Then when you want to start adding, like, say I want to start adding some objects, I can right click and I can go to add primitive shape. Say I want to left click on the cube. This is giving me an X times a Y, your width times your length, and then your Z is your height of your cube. So it's going to call it dynamic and respondable. So we're just going to stick with whatever is the default here and create our cube. So here's our little guy, and see the little 3 lines inside, the green, the red, and the blue are indicating the X, Y, and Z axes. And if you see over here on the right hand side, the X, Y, and Z axes are aligned with the red, blue, and green inside the cube. And those are indicative of the scene viewpoints. If I double click on the cuboid in the scene hierarchy, I can say cuboid 1, and then I'm going to double click on the little turquoise cube, and then I get this dialog box that pops up. I'm going to change the color, go to ambient diffuse component. I'm going to make it, so I made it like this cool like fuchsia magenta color, whatever. And I can go to add, see on the top left, go to primitive shape up here, I can add a sphere. So what I wanted to point out was that you see how it says sphere up here above the cube, and it's because it plots it right in the same spot that it plotted the the cube. So in order to move it away from the cube, I need to go up to the top left. You see where it says Object Item Shift? And I click on that, and then I can see how it has my hand for my mouse cursor. I can click it and then move it out like this. And then, since it's still selected, I can go ahead and click on the properties again, go to color, and we'll adjust it just to add some fun to it. And then this one I'm going to show you how we can also add some texture to it. I'm going to click on texture. So when I go to select texture from existing textures, you can also load new textures. There's only one that comes in that's like default in your trial software. So I'm just going to click that, and then you'll see how it's a nice, smooth, shiny ball right now. And when I click OK, now it looks like more like a beach ball. So now it has some texture. Now say I'm going to add maybe one more just to give you a little diversity here with a cone. And again, it's also right in the spot of the cube. So I can either move the cube away so that I can always see when I plot a new shape, geometric shape here, well, I had cube already highlighted, so in this case I'm just moving the cube. But otherwise I'd have to select cuboid over here on the left under scene hierarchy to move that out of the way. And then going back to cone, you see how it's a little bit transparent here? So that's because the way that it's preloaded, I'm going to go ahead and change the color. Get a little turquoise here, a little bit here. So there's another property that I want to show you when it comes to these geometric objects. So there's a feature that you can, there's 4 ways that you can describe an object, and 2 of them is a must. So that gives you the combination of these 2x2 properties. You can either have them as dynamic or static, and then you can either have them as respondable or not respondable. So when you have a dynamic or static, say I have this cube and I'm going to call it, go to the dynamic properties dialog. So see here where it says body is respondable and then the body is dynamic. So remember the respondable feature means that basically the body is reactionary, so that if something comes and hits it, it's able to move and also standing on its own. So it has a defined boundary, but it also is movable so that it does perceive forces whenever they interact with its boundary. And then when you go to the body's dynamic feature, that's basically allowing it to interact with whatever forces is in its environment, not just that whatever changes on its surface. So the environment part is like gravity and as well as like, you know, the floor, collisionary forces, things like that. So what I'm going to try to do right now is try to demonstrate the difference of these 2 features based on using the shapes. So what I'm going to do is try to create another sphere, and this one we're going to make it black, so we can differentiate it from the green guy with texture. Okay, so this one on the dynamic properties, I'm going to call this one respondable, but not dynamic. Okay, We're going to come over here. I'm going to show you how to rename it. And now under the scene hierarchy, when I double click it, where it says sphere, I'm going to say black ball, respondable, and then only. Okay, and then on the sphere, I'm going to call it, you can go green ball. And I'm going to say respondable and dynamic. Alright, so going back to the black ball, I would like to put this on top of the cube. So I'm going to say preferred axes, I'm going to include the z-axis and the y-axis. So it's going to go along the y-axis. Oh wait, this is y-axis. I think I went x and z. I'm going to go along the x-axis and go on top of the z-axis. See how I can go this way, x-axis, and then I can go on top of the cube, which is z-axis. Okay, so I'm going to set that down here. And when it says relative to, when I say world, I'm referring to the entire scene. If I say the own frame, that's only relative to however I place it inside of its little frame box. So in these cases, I'm going to show you the difference between parent frame and world once we get these two guys conjoined. So let's see what it does based on being respondable only and not dynamic. I'm going to hit the simulator button, and we're going to see if it can sit on top of the cube. Okay, so we're good. Sitting on top of the cube. Now I'm going to change it and say, what if it's dynamic only? Just so I can try to show you and remember for myself the difference. Now we're going to call it dynamic and not respondable. So let's see what that does. And then we'll simulate again. Simulation is this little play button up here. Oh, it fell right through. So the reason it fell through is because it's dynamic, so it interacts with all of its environment, including gravity. So gravity was pushing down on the ball, but it was not responding to any of these other objects that were acting against gravity. So that's why it only responded to gravity and nothing else, and it fell right through everything. So a little bit of physics here in this program, and that's actually the basis of how it creates its hierarchy. So the geometric shapes get preferential treatment, and what that means really is just that they're more simple. So they're more, you can program them more, like everything is a little bit more straightforward. And anytime there's a hierarchy of actions in the simulation, then these geometric patterns, which are much more simple, are given first dibs in an environment, and then anything that's more complex and around these geometric shapes, they are given secondary priority. So they kind of have to, like if both of them are static and stuff like that, then the geometric guy is going to get the static treatment first. So he's going to be stronger basically than the robot. So that's what that's saying. If they're set the same. So you can control also mass and things like that. And I'm going to try to see if I can show you that real quick too. I'm going to set this back to respondable. And keep it like this. Trying to remember where the mass. It's the mass. When I find it, I will come back and show you. Okay, anyway, so let's start with these guys, and now I want to show you how you can pull in other robots and things to interact in this environment with these different concepts. So, say you click on anything that you have in your model browser, you can click on those folders and then pull up whatever they have as models. These are going to be like usually .obj files or TTM files. You might find them. Coppelia actually has a GitHub full of TTM files, and I'm going to show you that in a second. I just want to show you the basics of how to throw these guys onto the floor and get them running into a simulation. So right here we have a robotic arm, and then we have a little hexapod. And the hexapod is mobile and it runs around. The robotic arm, of course, is stationary. So this guy, the arm is dynamic, or is static, and the hexapod, of course, is dynamic. So say we want to take the hexapod and put it right here. And say we want to move the simulation down a little bit and get it kind of in a good scene so we can see what's going on. Say, let's just run it and see what happens. So see how it's flexing all of its joints, it's flexing all of its abilities back and forth here, to and fro. And then it runs off the floor. So you see up here, the minutes are still running, milliseconds, until you stop the simulation. So what if we check out what this hexapod is doing? So as soon as we dragged and dropped the hexapod from the model browser part to the floor, it automatically added the hexapod to our scene hierarchy. So you see that each one of our objects in the scene is parallel to each other. And I say parallel like they're like on the outer layer as independent of each other. But the hexapod itself has a plus next to it, and what that means is that within the hexapod, it's actually just a compound of a bunch of different dependent shapes. So the joint is indicated here. There's 3 different kinds of joints you can have in the simulation program, and that is it's like the long cylinder around the peg. You could have the prismatic, which is like the long cube around the peg, and that's for linear movement. And then you can have the shoot, what's the name of it? The translational one or something, that torque. I'm sorry, that's for torque. So it's like a disc around a ball, and those are 3 different kinds of joints. It basically is to measure pressure. The torque one is. But these other 2 that are for like degree movements, degrees of freedom, the prismatic one, that's this cube, like a elongated cube around a peg, that one's just for linear movement back and forth. And then the round one is around so that you can, the round one is more like a circular, so that you can move around, and that's what our little hexapod guy has. So when you double click on these joints, you can see their positions are relative to the point that they're going through, like the axis that they're laying on. So I'm going to give you a better, more zoomed in version of that in a second. I just wanted to give you a basic overview of what this is, so, and how it fits in the scene. So we saw how this one, because it moves, it's a mobile bot, it moved right across the floor onto the edge. So say that I wanted to see if I can add another cue. I did a Control C, I highlighted it and I pushed Control C. Let's see if I can Control V. Yes, it let me. And so I'm going to go up here to the Object Item Shift and pull that over here. Now this is cuboid 1. I'm going to double click it and call it cuboid new. Actually, I'm going to call it blocker, because I'm going to try to block this little robot. It's relative still to the world. Position was changed when I moved it, and I can change it again. See how it moved. These coordinates, because the coordinates are relative to the world. And then so now when we simulate this, I want to see what happens to the hexapod and the cube when they meet each other. So I'm going to check out the dynamic properties that make sure that the cube is both respondable and dynamic. properties of hexapod and see that it also is respondable and dynamic. Now I'm going to simulate. So you see that it collided with the block, and then it moved around, came back and looked for the block. Now when we set it to, we'll set the hexapod to respondable but not dynamic. We made it static, see? So now we'll set it to dynamic but not respondable. So here you see that it was far less involved with the surroundings of its environment, and it fell off the floor. So this is where I want to show you a couple of different things we can do. So let's say we wanted to add some more elements or objects to our scene. We could go download some stuff off the internet. You could look on the internet for objects, and they would be in the form of .ttms. So say we went back to this Coppelia website, and you scroll all the way down to find their GitHub. In their GitHub, you can go to models, and all these models are different objects that you can download. I'm just going to show you like this nature one. You download trees, so anything with a .ttm is going to be what you're looking for. So I downloaded a few of them already before we got here and put them into this folder, in my downloads folder. All you have to do really is just drag and drop them to your Coppelia folder, and then open up your CoppeliaSim Player. So again, that was, remember, this is your path, C, your program files, Coppelia robotics, CoppeliaSim Player, and then mine was called imports, and I'm going to put it in my models folder. So now, when I open models, instead of having only examples, which we see up here in the model browser, I also have imports. So, but in order to see these, you see it doesn't populate right away, so I'm going to have to close it and reopen it so that those are going to show up under my model browser. So now we have not just examples like we had before up here, but now we have all these imports that I uploaded or downloaded beforehand, and now uploaded to the software. So say for example, we wanted to put back, this robotic arm this time. So now, this is what our new scene looks like. Now I'm holding down the control key and scrolling up on my mouse to get it to zoom in like this. And then I'm going to add some infrastructure and a wall. I'm going to add this external wall. basically it's just adding some boundary here. What that's going to do for me is if I want to go back to my hexapod, throw this guy in here, now he's not going to be able to run off the floor. So, and that's because he is dynamic and respondable. So the respondable feature allows him to bounce off the wall and recoil. So when I hit the sim though, now that I have both the robotics arms, which you see over here under scene hierarchy, it's identified as this LBR name right here, and then under that is the external wall, which I put after that, and then the hexapod. You see all of these are parallel in their priority feature. So none is dependent on the other, they're all completely independent. When I hit the simulation button, they're both going to go at the same time. Those that have the moving parts. The robotic arm finish first because it's more simple, and then your hexapod is flexing all of its abilities and trying to figure out how to go. Looks like it has a little damage joint there. Okay, so and then when we hit stop, everything goes back to the initial state because that's how we have it set. And those are settings if you play around with your user settings and stuff. You'll be able to find them. Anyway, what I want to show you now is the parent-child relationships of your models. So as you load these up, you'll see that all of the joints and links are connected, like we talked about earlier with the hexapod. They're all sequential. So it's really easy to tell with the robotic arm because the first layer is going to be your base. So if I highlight the link, then you see it's highlighting this area down at the bottom that's sitting right on the floor. So it has the same dialog box as everything else that we've looked at so far. You see that it's not dynamic because it's static, that means it can't move around, and it's not respondable because it's not going to be budged by anything that hits it. So the next link after that is joint, and that you can see how it's highlighting the joint on the inside that comes between the base and the next link. But if we didn't highlight this in our scene hierarchy, we would not be able to see that link. But since we're able to do that, we can now see the shape and its orientation, as well as the axes that it involves. So you see that it's a prismatic joint, whereas we couldn't guess that just by looking at it from the outside. So, but by nature of it being a prismatic joint, we know that it's a linear joint. And so when we flex it to move, we can see how the axes actually move around. If we click this little turtle up here, we can see it move more slowly. So we can really evaluate how its movement's that way. Okay, so another thing that's pretty cool about this, the parent-child thing, is that say we wanted to see how the top of this robotic arm has an open-ended connector. So say we want to add something to it, like a hand. So we can go over here to the stuff we imported, and we can go to components and grippers and take this hand. Put it over here. Now we're going to have to call the hand. We need to stack it just like we did the sphere on the cube. So, and that's a little tricky for me because I don't have a lot of practice with this yet, but I'm going to try. So we're going to click on so when we click on the little egg next to the Jiggle hand right here in the scene hierarchy, we get the dialog box, the dynamic properties. We see that the body is respondable and that it's dynamic. So that means we can move it around, it's not static, and that means it is reactionary to the forces surrounding it. So we're good to go. And we're going to just go up to the top left of your menu up here, go to Object Item Shift. We're going to put it around the base area and the XY part, and then we're going to click on it along Z, which is going to automatically take away from either X or Y. That's fine, because we just want to go up right now to put it on top of. See that little red peg is that final joint, and that's what we want to connect our robotic hand. So this time it seemed to fit exactly. If it's ever off a little bit, you can just get it up to about the right level and unclick the Z and re-click the X and Y and just, go around with it. You could also do the positions and look up the precise positions of everything using your coordinate axes. So now that we have it on top of the robotic arm, it's important that we have it move in tandem with the robotic arm so that they're moving together. So to do that, we're going to have to we can basically just drag and drop this Jayco hand item object. See how it's parallel with the hexapod and everything else, the wall, everything. We can just drag and drop it and put it underneath the LBR name representing the robotic arm, and then it automatically lands. We'll see when we expand the box, but it lands in the outermost child folder, so it's going to be parallel with the link and the joint, which are the very first two. This is the base and then the very first joint, so it's going to be moving dependent alongside those guys. So anything that comes after the joint that's above the base is going to be still moving independent of the hand and only dependent on the bottom joint and base. So it's important that we're able to move the Jayco hand onto the connector, which is what it's actually sitting on top of, the very bottom end of the line basically, so that it's moving with the final forces. And then we can adjust it so that all of its movements are dependent on the parent frame rather than the world. So we want to make sure so when you click on the moving thing up here, the object item shift, you're going to get this dialog box. You want to make sure the parent frame and not world is selected. So on position, translation, and also the position scaling. That means anytime that the arm moves around and becomes closer to you in your visual field, or it also rotates in perspective, that the hand is going to behave in tandem with the robotic arm visually to you. So you want to make sure that the parent frame and not world is what's selected. So let's give it a little trial here and throw our simulator on. You see they're connected, and there it is, behaving perfectly. It even pinches all perfectly. That makes me happy. Okay. So, and just to show you what other things we have here, we have different kinds of wheels. If you're building your robot from scratch, we've got sensors. Now the sensors are not available in this free trial version. To be able to add the sensor capability to this, so to be able to add the sensor capability to the simulator, you would have to be able, you'd have to have either the EDU or the paid version, and you would find those here under add. You have a long list of different things you could add. A lot of they're like proximity sensors, and then you can add the ultrasound and all the different shapes, array sensor, and those are beyond the requirements of the videos. I'm not going to show you those right now. But just to show you the different things you can also add a tree, put a tree over here. And then we can add some fire right here. We got some little robots here. Yeah, so there's a lot of things that you can still add that are still free if you just go to their the CoppeliaSim GitHub website and download them piece by piece, and then you can build different scenes and have them interact with each other. So, but this is basically the. Oh, and there's something else I want to finish showing you the menu up here. So now we know how to scale and move around. We can rotate objects. So say now I'm clicking on nail. That's this little guy I just put here. And then I click on object item rotate. I can make him face a different direction. And then you can also let's see. Oh, this page selector means that you can click on that and see all the different visual perspectives of the scene. So you can also do this actually after you hit simulate. So let's go ahead and do that so I can show you. So I'm going to start the simulation. Everybody starts, and then we're going to hit the page selector. You can see the fire going, and the robot walking around, and a little hexapod. You see all the different perspectives. It's pretty cool. So you get a lot of capability with this free version. So thank you guys for coming by, and if you'd like to get more in-depth and professional tips, feel free to look up the Leopoldo Armesto on YouTube. He is the king of this stuff. Let me write it down for you. Yeah, this guy. He will show you all the ins and outs and everything in between. So, thanks for joining, and thank you, Dr. Zhang. I will see you in class. So a kind of sad fact about the trial version is that if you download a bunch of models and you put a scene together, I can't figure out a way to save it. So maybe y'all can find a way, but yeah, unfortunately. But you know, a cool thing is that even though I couldn't add any sensors from using the add menu, is that I could still add models that have sensors. So this little R2-D2 guy in the middle, those red parachute cone things are sensor ranges. So you'll see when I run the simulation, he's going to shoot out, see those black and yellow sticks coming out of him? Mean that something, he's picking up some, he's detecting something in his sensor range. So it's still really versatile as a trial software. Anyway, thanks for coming by, y'all. If you stuck it out, thank you.